How do internal energy, enthalpy, and Gibbs free energy differ in chemistry? Imagine a chemical system as a tiny universe of energy. Understanding how energy moves and changes inside this universe helps us grasp how reactions happen. Today, we're exploring three key energy concepts: internal energy, enthalpy, and Gibbs free energy. Each one tells us something different about energy in chemical processes. Internal energy is like the total amount of energy stored inside a system. It includes the energy from moving molecules, chemical bonds, and microscopic interactions. Think of it as the sum of all the tiny energies that make up the system. It does not directly consider how the system's size or pressure change, just the energy contained within. Enthalpy builds on internal energy by adding the energy needed to make room for the system under pressure. It is calculated by adding the product of pressure and volume to the internal energy. This makes enthalpy especially useful when studying reactions that happen at constant pressure, like many chemical reactions. When a reaction occurs at constant pressure, the change in enthalpy tells us how much heat is absorbed or released. Gibbs free energy combines enthalpy and entropy, which is a measure of disorder or energy spread in the system. It is calculated by subtracting the temperature times entropy from the enthalpy. This quantity helps us predict whether a reaction will happen on its own or need extra energy. If the change in Gibbs free energy is negative, the process can occur spontaneously. If it is positive, external energy is needed to make it happen. To sum up, internal energy is the total microscopic energy inside the system. Enthalpy includes internal energy plus the energy to accommodate pressure and volume changes, mainly useful for heat transfer at constant pressure. Gibbs free energy combines enthalpy and entropy to tell us if a reaction will happen naturally and how much useful work can be obtained from it. In terms of chemical energy, think of it as stored in chemical bonds. When bonds break or form, energy is released or absorbed, affecting enthalpy and Gibbs free energy. This helps explain why some reactions happen spontaneously while others need a push. By understanding these three energy concepts, we can better see how energy flows and transforms during chemical reactions, making the invisible world of molecules easier to understand.